Welcome to Buildings and Beyond,
the podcast that explores how we can create a more sustainable built environment
by focusing on efficiency, accessibility, and health.
I'm Robb Aldrich.
And I'm Kelly Westby.
In this episode, I talked with Charley Stevenson from Integrated Eco Strategy about sustainable materials and healthy materials. He's been looking at this for a decade or more, healthy materials in buildings, and I really learned a lot. This is something that I am finding that I'm more and more interested in. We talked for a long time, quite a long time, so long that we had to edit it down and break this up into a couple episodes, but I'd learned tons. I hope you get something from it too. In this episode, for the first 10 or 15 minutes, we talked about mostly about the Living Building Challenge, which is a program that I'll let Charley describe in more detail, but healthy materials is a big piece of the program. And then we talk about how to find out information about materials, what databases are out there, how to source sustainable materials, what to ask manufacturers, who is keeping track of all this info. And listening back to the episode, actually, I realized we threw out a few abbreviations that I thought maybe would be good to define up front. HPD is a Health Product Declaration. ILFI, International Living Future Institute, which is in charge of the Living Building Challenge program. And SDSs, or MSDSs, Safety Data Sheets, or Material Safety Data Sheets. I thought those might be helpful if you are not familiar with those. But here is part one, my interview with Charley Stevenson. Well, first of all, thank you for being here. This is an important topic, healthy materials, sustainable materials. And I know you are very involved with Living Building Challenge projects, yes?
Correct. We started our first Living Building Challenge project in early 2011, and that seems like a long time ago.
Yeah, right. And I listened to, actually you were mentioned, I listened to the Green Architects Lounge podcast, and they talked about the Living Building Challenge project or two. And they mentioned you, and they mentioned that the materials Petal, the materials piece, is the toughest. Do you hear that a lot? Is that?
It's, so I would put it this way, so the materials Petal is the biggest surprise among the challenging petals. So, in Living Building Challenge, there are 7 petals. 3 of them are highlighted as particularly challenging: energy, water, and materials. The energy petal requires net zero, or in some cases net positive energy. And I think there are lots of rules of thumb that have evolved over the years. And project teams can look to a pretty substantial set of case studies and understand, generally things are converging toward heat pumps and triple pane windows and, certain levels of air infiltration, etc. And in so doing, they can pretty reliably get to net zero energy. The water petal is a different kind of a challenge, simply because it's a regulatory challenge and an operations challenge. The requirement that a project produce and treat all of its own water on site from, by and large, from rainwater. There's a way to do it with if you're outside of a city, you can do it with groundwater and a pretty standard septic system. But in places where there's municipal water and municipal sewer, convincing first a client and then later a regulator that it's a good idea not to use that system water is an effort. So I think the water petal will remain a challenge for the reason you're replacing, small sections of pipe with technical systems that need to be designed well, and then are really relying upon rainwater, other precipitation, and then sort of continuous operation issues. And again, there's practice there and there are precedents there. That's a bigger lift in terms of scope add than net zero energy is at this point, or net positive energy is at this point.
Yeah, that also makes sense. It seems like a bigger, more non-traditional systems and approaches.
Right. At the single family level, it can be very straightforward. I mean, there are a lot of LBC projects in suburban or rural areas where it looks a lot like a conventional drilled well and a conventional septic system, and that meets the intent of the Living Building Challenge, presuming that there's enough rainfall on site to demonstrate aquifer recharge. The materials petal, on the other hand, sounds simple in principle: avoid carcinogens and endocrine disruptors and bioaccumulative toxins when possible. That unpacks to be a task that touches 100% of products, or very nearly 100% of products that go into
is that it? Did you just is that like the whole requirement of the petal that you in that one phrase?
That's the red list portion of the petal. So the petal in Living Building Challenge, a petal is the sum of one or more imperatives. So the energy petal is a single imperative: provide 105% of annual energy needs from on-site renewables without combustion. That's not verbatim, but it boils down to that. The materials petal has a couple of different facets. One of them is the requirement I just mentioned to avoid so-called red list chemicals. These are chemicals of concern, about 800 specific chemical abstract service numbers, on the order of 25 chemical families of concern. So that's one piece. Another piece is net positive waste. I'm not reciting these in order. That imperative looks at really 4 phases of the project. It looks at the design phase. Is it designed to minimize waste? It looks at the construction phase. Are resources brought to the site repurposed and salvaged and diverted from either landfill or incineration to the highest extent possible? The third is the operations phase, asking the question of sort of responsible resource stewardship. That's on-site recycling, that's composting, that's sort of making sure that as the building is used, it's not contributing to a waste stream. And then finally, end of service, 50, 100, 200 years down the road, what care has been given to in the design and construction phase to ensure that the materials aren't destined for landfill or incineration down the road. So some of that's designed for disassembly, some of that is flexible structures so that if a building, it's set up to be adapted for future use rather than demolished and replaced. So that's another piece of the materials petal.
So the I guess the health piece, the healthy materials piece is the red list, as you mentioned, but then there are the 3 others.
And then there's embodied carbon.
Oh, there's one more.
Yep.
I was wondering. I was going to ask you about that. I thought you said that was the last one. Okay.
Oh no.
Right.
I've learned not to number my lists before I start talking, because I'm always wrong when I do that. No, embodied carbon at this point requires project teams to, using Tally within Revit or using the Athena tools to calculate embodied carbon for the project and its renewable energy system, and then purchase a one-time carbon offset at the start of the project, effectively to pay back the carbon debt, so that embodied carbon is covered, and then the operational carbon is covered by the on-site renewable system, so that the project truly is carbon neutral in construction and operation.
And that includes extraction and processing and shipping, that piece of the Petal?
It does, using libraries. So we're not studying, how many trucks come to a project on a given day, or how many hours are put on an excavator. That's all covered in tons of concrete and square feet of drywall, and basically looking at, in the simplest terms, looking at the assemblies and then using industry standards to assign embodied carbon impacts to the volumes of each assembly type.
That makes sense. And I mean, there's a lot to it. I mean, and this is, I mean, correct me if I'm wrong, but this is the most rigorous formal program looking at materials, sustainable materials. Yes? It's
the most rigorous one I know of. I'm imagining there's something out there. I mean, the way I see Living Building Challenge having evolved, it certainly wouldn't be possible without USGBC and LEED. If we accept that LEED is an evolutionary process, and it certainly has evolved, it continues to evolve, and in each iteration, LEED gets more stringent, with the idea that it's moving toward sustainability. It's moving, over time, years, decades, it moves to a place of positive impact, that no harm is allowed to be caused by a LEED project. So certainly there are LEED projects that are net zero energy, for instance, but there's no requirement. So the notion in LBC is to say, what's the logical extension? What would true sustainability or regenerative design look like? It wouldn't necessarily be that we stop at a project that's 30% better than code energy use or 50% better than code energy use. Let's take that to the place that looks truly sustainable or looks future-proof, and that would be net zero energy. So effectively, in each sector of green building consideration, we follow that evolutionary curve to the point where it looks neutral or positive, and that's the starting place for the Living Building Challenge.
Makes sense. Going all the way, and I personally have been involved very only tangentially in a few Living Building Challenge projects. I know others in our office have been much more deeply involved, but it's ambitious. It really is, and it's off-putting. I think many of the Petals can be off-putting. The materials one, maybe more than the others. A
friend, Bruce Coldham, described it as a Trojan horse. It seems really straightforward, and then you welcome it in, and it starts to unpack inside the gates of a project, and it's you've
a nice metaphor.
You've committed to a lot, and you might not, particularly in the early days, you might not have realized quite how much you committed to.
But this is what we just discussed, talking about perhaps the Red List and LBC. I think you used the phrase wading into LBC, not diving into LBC. There are some less heavy lifts that can make a big impact to indoor health, to overall embodied carbon of projects. And I think that some more accessible pieces might be, more accessible.
Right. So I think that's one thing I'm really looking forward to talking about. Another piece is that the market has evolved a tremendous amount since the advent of LBC. So, the way projects work, most have, and LBC projects in particular, they may have a 3 or 5 year life cycle. So what's begun it's, the stories that current projects are telling are quite different than the projects that, or the stories told by projects 5 and 10 years ago. Back in 2011 and 2012, we were a smaller operation, and there were two of us, and we could hear one another, in an open office, and it generally took 5 or 10 minutes on the phone to describe to a manufacturer or an engineer, product engineer at a manufacturing firm, just what the living building challenge was. So if we were on a research task, we had to plan on stopping and giving background. It is no longer the case that it's very seldom, I should say, the case that we call a manufacturer and have to explain LBC. So just that fact alone means that the effort required by a particular project team is vastly reduced because there's familiarity. And I think so that's one thing I would want to make very clear, is that while it remains a challenge, a lot of the war stories from early projects are now somewhat outdated, in the sense that it has gotten significantly easier. And
Excellent.
Another piece of that is that, unlike, say, the water Petal, where it's a new regulatory lift for each new project, materials can be fairly consistent from project to project. So once a single project team has determined a good drywall or an appropriate non-flat interior latex wall paint, that is a really good starting place, if not a good solution for subsequent project teams. So because information can be shared, and because there's the possibility of reuse of compliance information from project to project, the community of practitioners can facilitate future materials project compliance paths for all subsequent projects. So there's that idea of data reuse and information sharing is I would say much more significant in the materials Petal than it is in others.
And you manage a database. The Red to Green database, I believe, is your product that you have kind of compiled over the years. Is that?
That's true, yes.
accurate?
So I think almost all LBC project teams begin with a spreadsheet. So the International Living Future Institute has a template spreadsheet that's effectively the reporting form that needs to be submitted for audit at the end of the project. So everyone begins there. There's certain information that gets tracked, and it's a subset of all of the information that's collected over the course of researching a product for LBC compliance. So the quick story of Red to Green is that we had our first Living Building Challenge project at Williams College, and then about 2 years later signed on to do one at Hampshire College, just about 40 miles away. We thought it would be really easy because we had all these answers from the first project. And lo and behold, we'd forgotten a lot of what we'd learned because we didn't write it all down. And then we started our third project, the Hitchcock Center, also on the Hampshire College campus. And those two projects had the same construction team and were overlapping in design and construction. There again, we ran into the limitations of a spreadsheet. First of all, it didn't contain all the information that we'd learned. And then on top of that, there weren't enough dimensions in the spreadsheet to keep track of what was consistent from project to project and what had changed from project to project. So we started a database development process to take advantage of the many dimensions that a database allows. And over time, that's evolved to be a software platform that's focused on LBC materials compliance that we call Red to Green.
Because the red list, I hear quite a few people mention the red list, but the red list is not a list of products. It's a list of chemicals that are not allowed in any products that you use in an LBC building. Is that accurate?
That's correct. So the red list is you could say worst-in-class chemicals. So you're
Okay.
familiar with some of them: asbestos, lead. You know others by name, BPA or PFAS. Even something like BPA isn't a single chemical. That's a chemical family. So I won't know the numbers off the top of my head, but there are dozens of BPAs. There are polycarbonate BPAs and so forth and so on. So we sort of start with the idea that we're going to avoid BPA and then need to delve much deeper to find specific chemical compounds revealed by manufacturers which may or may not be BPA. So there's a lookup process that we do when screening a product.
Gotcha. And that so is red to green kind of basically all the products in that database do not contain any red list chemicals. Is that accurate?
It's not quite so simple. So how will I put it? So we've looked at something over 9,000 products, and we sort them into categories. There are a couple of different ways of sorting. Sometimes we know all that we need to know about a product to make a determination, and other times we don't. It's still the case that not all manufacturers will reveal 100% or anything approaching 100% of the chemicals in their products.
Right.
And there are a couple of reasons for that, some valid, some arguably less valid. Sometimes they just don't know. So I'm sitting in a chair which has, I'd guess 150 parts. There are the arms, and there are the screws that hold on the arms, and there are the little plastic levers that let me adjust the arms. It's quite possible that each one of those comes from one different sub-supplier, and it's also possible that like a screw that has a black coating might involve 2 or 3 suppliers. So just the act of figuring out what's in a chair sounds straightforward. It's non-trivial.
Yep.
And then so sometimes it's just a data acquisition problem, and we're totally sympathetic when manufacturers face that. Other times we're also sympathetic, but we're when there's a concern about proprietary information. That's to say, a team has, a company has invested significant resources in figuring out how best to make a flexible coating that could go on the arm of a chair in this example. And they don't want to reveal how they made that, because understandably, if they gave the chemical recipe, someone else would have a shortcut to replicate their high-performing chair arm coating.
Yep.
The trick in all of this is that, as a consumer or as a designer that's recommending products to consumers, we want to begin from a place of information that allows us to make informed decisions. So it's very different to say, in the case, if we switch to food as an example, the difference between "trust me, it's organic" and "I have a third-party seal from the Oregon TILF saying that this fruit bar was produced organically, and it contains only fruit, as opposed to preservatives or other synthetic chemicals." So, I think I take materials health to be a 2-step process initially. First, obtaining disclosure, so that information sharing, and then second, a screening process to understand and judge for myself using sort of established rules of health and potential health impact, to understand if a product screens positively or negatively against those lists of chemicals of concern.
Yeah, okay. And so where's the best place for, I mean, looking for HPDs, which stands for
Health product declarations.
Okay.
So it is still early days for getting this information. And
Okay.
there isn't a standard. So there are multiple standards for ingredient disclosures, all of which are good and maybe none of which are perfect.
Yeah. No, it's very confusing. There's all kinds of different sustainable product certifications. It's a little alphabet soup that I don't know exactly what to make of them all personally.
Right. Well, and I wouldn't claim that I know what to do with them either. I think the way we approach it, and we talk about wading into this, potentially overwhelming pool, just pick a couple of criteria that seem to make sense. So, on the simplest level, is it good to know what's in a product? Better, that is,
Yes.
than not knowing. So, yes. And then it doesn't need to be 100% disclosure. Is it good to know something rather than nothing? Sure. So if you look at a safety data sheet, for instance, that does not reveal 100% of material ingredients, but it will flag certain chemicals that are known bad actors. So that's sometimes. Well, that's to say, there are regulatory requirements to reveal certain things. Now, there are other bad actors that aren't subject to regulatory requirements, or
Okay.
So if a product contains formaldehyde, for instance, it will show on the SDS.
Gotcha.
If it contains BPA, it may or may not show on the SDS. Someone could choose to put it on the
Okay.
SDS, but they're not required to put it on the SDS. So that's a good first screen, because many products are required to have them. So if any chemical constituent that's a proven carcinogen will be revealed through the safety data sheet.
Good.
If we move on to something like a health product declaration, that's a voluntary standard. It's fantastic because it is a standard. So there is an increasing level of consistency from manufacturer to manufacturer. It's good that it's an evolving standard. So, the Health Product Declaration Collaborative does tremendous work in industry, helping manufacturers understand the benefits that accrue from disclosure. And then over time, that standard evolves, moving toward higher levels of disclosure, which is to say, moving from, say, 1,000 parts per million as the threshold for disclosure to 100 parts per million as the threshold for disclosure. So there's fewer places for chemicals of concern to hide as you move toward a more stringent screen for ingredient disclosure.
Cool.
So all of these resources are tremendous. What they do is they bring information out into the light for review and reflection by project teams.
Yeah.
So as we reach higher and higher levels of ingredient disclosure, we now get to the next question. Great, I know what's in this product. Should I use it? And it's an entirely different question, because that we presume some knowledge about chemicals of concern in order to answer, move from the factual question to the guiding question. And then again, there are lots of tools. There are something like the red list gives us a way to ask the binary question: does this product have a chemical that someone else has said I should avoid? So in the case of formaldehyde, it's a carcinogen. I understand intuitively that given a choice, I wouldn't use that in a building.
Yeah, I ran across something. I ran across an article that was a pretty general article or paper that advised avoiding mastic for duct sealing. Use tape instead of mastic for duct sealing because mastics contain many chemicals of concern, and they were talking about just generally. And so this kind of floored me because mastics are so much better at duct sealing than tapes usually that I was I was a little concerned. So I went through, I looked up a few SDSs from some mastics that I had used that I knew about. And, you know, the compounds listed on the SDSs accounted for something like 17% of the volume or the weight of the product. So I was like, oh, man. And then so I dug a little more, tried to find some mastics with duct mastic with product declarations, HPDs. Still looking, did not find any. So it's frustrating because you know.
Right. Well, it gets to be this, you know, the how will I put it? You can't unthink these thoughts. We wouldn't accept, food that we ate every day. Well, we might change our diet if someone said to us, what you have for breakfast every day, I can only tell you 17% of what's in it. And that leads to that question, well, what's the other 80% or 83%? And if someone were unwilling to tell you, you might go looking for a different breakfast.
Yep.
And
absolutely.
And often, though, it's possible that the other 83% is inert, but wouldn't you feel more comfortable if you knew that?
Absolutely.
And it gets to a really good point, Rob. That's that one of the biggest threats. That's too strong a word. A consideration in design is to avoid single variable optimization. So it is absolutely true that mastic produces, duct leakage with a higher effectiveness rate. That's the wrong word. And
lower duct
leakage at a known installed cost.
Right.
So if you ask the question, what's the most cost-effective way to reduce duct leakage? The answer is mastic. If you ask the question, what's the most effective way to deliver uncontaminated air to building occupants? You're introducing a new variable in the discussion, and that's uncontaminated. And leakage reduction is great. If it comes at the expense of a contaminant load, it may be less great. And now what the optimal solution focused on leakage alone might be mastic. We may be willing to accept a higher leakage rate in exchange for a reduction in chemical load. And now we're really asking a different question.
Or somebody can step up and make a mastic without any red list chemicals.
Exactly. Well, and that's really, the entire premise of the Living Building Challenge is precisely that. No one stepped up and delivered a red list free. Oh, I don't know this. I could look it up. If someone hasn't delivered a mastic that's free of red list chemicals, it's probably because no one has asked them to yet. So
gotcha.
What we end up doing as practitioners in this realm is just asking the question, hey, what's in your product? I'd really prefer a mastic that contains no red list chemicals. And that does a couple of things. First of all, it alerts the manufacturers that there's an interest, that there's a market here for a red list free product. It alerts them to something that they can act upon. So it's not just that I want a healthy product, it's that I want a product that doesn't contain anything in these 25 chemical families. Some of them are going to be easy. Yeah, we don't put asbestos in our a mastic, though it might be legal. We don't put lead, but there may be some plasticizers that we'd have to look at and come to a better understanding internally, speaking as the mastic manufacturer, to know, do we have it now and can we reformulate without? And to a topic you touched on a little bit ago, there may not be a perfect mastic. And then a design team is left with the question, are they better off with a leaky duct or a duct that uses mastic to achieve a certain level of sealing? And that decision is left to the design team. So I don't think in terms of absolutes, but rather think in terms of the best that we can do for a particular design problem. So,
Yeah.
When we finished an LBC project, as much as we'd love to say it's red list free, really what we're saying is that use of red list compounds has been minimized. So we're using them in known places for known purposes. So an example of that is a fire alarm. We have not found a red list free fire alarm annunciator. But we believe there's very good reason to have fire alarms in buildings. So, and code officials agree. So,
Yeah, right.
So what we'll do in that case is we'll advocate to the manufacturer and say, we have this red box. You didn't tell us what the coating was on that box, and we can deduce that it contains lead. That's fine. We accept that this is the state of the market for now, and to have a safe building, we want a fire alarm system, and to have a fire alarm system, we accept these shortcomings in current disclosure and compliance. Please know that when you or one of your peers has a product that does better than this from a chemical perspective, we'll shift our purchasing there. So
Yep,
we're engaged
good.
with the market as it exists, but we're telegraphing what we want the market to be in the future in an effort to tip the market toward optimization. And the idea there really is that Living Building Challenge teams individually may or may not have a lot of power, but collectively they define the terms, red list free, and they commit in the abstract toward buying better products in the future. So whoever's making the case for better paints or better coatings or better what have you can be accumulating this information to say, boy, if we'd win market share if only we had a red list free solution in this particular building product sector.
Makes sense, and we've seen the market change in this way, and in other aspects. Our accessibility group, I know, has had issues with high tech windows and doors. Not being able to, not having the proper clearance to get in and out of buildings, and working with manufacturers to get products that satisfy everybody. And if there's big enough demand, it's worth their while.
Right. Well, and so absolutely, we internally track what we call success stories, which are these breakthroughs with manufacturers, and many go to great lengths, and we appreciate their knowledge of their products, their knowledge of the manufacturing process, and they alone can pinpoint the shortcomings and then work within their supply chain and work to innovate in ways that addresses these concerns and moves either in large steps or incrementally toward better products, where in this case better is holding the line on all of the other performance criteria, durability, what have you, and increasing awareness of health impacts and really making efforts to reduce those.
Yeah, if anybody knows of a good mastic with HPD, let me know. I'd be very keen to find one.
So that's effectively, You'd hear the clacking. I won't look it up now, but I'll get you that answer, because effectively what we do is we're just cataloging what we find. So when I go back to those 9,000 products, some we have full disclosure, some we don't. In every case, if we're trying to ratchet toward fuller disclosure. And then certain products are red list free, certain products are red list compliant, certain products are red list unknown, and certain products are red list non-compliant. So that gradation, red list free, I think is obvious. Red list compliant, there are what ILFI calls temporary exceptions. So exterior sheathing, so plywood sheathing, it needs to be weatherproof for a few months. And no one has yet come up with a resin that lets a CDX plywood weather for a few months without delaminating, without using phenol formaldehyde. So if we want buildings to be durable, they have to stand up through the construction process, and they need to tolerate a certain amount of moisture. So the chemistry, the green chemistry, isn't there to give us exterior grade plywoods without phenol formaldehyde. So we'd love one, but for right now we have permission, and ILFI has given us permission to use that chemical of concern in this limited application until the market has transformed.
All right. So explicit, that's an explicit quote exception for now, not something design teams have to judge, but
right.
ILFI themselves
has given that permission. Right. So there's a whole, there are dozens of exceptions that reflect temporary market limitations. So part of what we're doing is we're attaching that exception to a particular product so that the next project team that comes along can see it's okay to use this. There's nothing better than this product in this particular market segment for the time being. And then, further down the list are the products about which we've not gotten enough information to make a judgment. And there's something that's called a due diligence case. So if we reach out within the bounds of a particular project to 3 manufacturers, none of whom will answer our questions, and we know of nothing else that can be used to meet the project's requirements, we can go ahead and use one of those products of uncertain compliance, because the work can't stop either in design or construction to wait for the market to transform.
Yeah.
And that's equally true for non-compliant products. So, back to the fire alarm, they contain lead. We wish they didn't contain lead, but we need them. So as we look at the library, it's about a third products that are compliant, a third products that are unknown, and a third products that are non-compliant. And where it gets interesting is when you have a particular design need or performance need that can be met either by a compliant product or a non-compliant product. Now you really feel yourself pushing the market or moving the market to say, no, we're not going to buy this thing that is non-compliant. We're going to favor this thing that's compliant.
Yeah, absolutely.
And I think back to your mastic example, this is where, it's an interesting process for designers to ask what products are necessary in a building. Is it the case that mastics are necessary? Maybe. Or there may be a creative solution that says we can achieve an adequate level of duct sealing without mastic. And now we're asking the question, well, what would replace mastic to achieve the desired performance level?
Absolutely.
So a lot of what we end up doing is we feel most impactful at the beginning of design, where we're able to broaden the question, to steer away from, say, spray foam solutions into bat or loose fill solutions. Because these are places where you can make a huge step away from chemicals of concern. You can also make a huge step away from embodied carbon. And now we're focusing on the performance in the abstract rather than the particular performance characteristics of a material. So it may be there's a different air barrier solution. It may be that there's a whole different wall assembly. But if with openness in the early days, you can often move toward products that meet multiple, that are optimized in multiple criteria.
That'll do it for part 1 of my interview with Charley. Next time we'll talk about where to start with healthy products or sustainable products. If you're not going to go whole hog with Living Building Challenge, where does it make sense to start spending effort to look at healthy materials in buildings? I also wanted to mention Charley's website, materiallybetter.com. There's links to that on our show notes, but I wanted to give you a shout out for that website too. Thanks, and I hope you tune in next week.
Thank you for listening to Buildings and Beyond. For more information about the topics discussed today, visit www.swinter.com/podcast and check out the episode's show notes. Buildings and Beyond is brought to you by Stephen Winter Associates. We provide energy, green building, and accessibility consulting services to improve the built environment. Our professionals have led the way since 1972 in the development of best practices to achieve high-performance buildings. Our production team for today's episode includes Dylan Martello, Alex Mirable, and myself, Heather Breslin. Thank you for listening, and we'll see you next week.